somewhere in one of the most politically volatile regions on Earth. Engineers are drawing up plans for a power plant so large it would be visible from space. A single energy project designed to generate more electricity than some European countries consume in a year. The price tag sits at $50 billion. The location is a desert that regularly exceeds 120 degrees Fahrenheit, and the goal is almost unthinkable. One nation wants to become the energy supplier for an entire region that has spent decades in conflict. This is not science fiction. This is already in motion, and almost nobody is talking about what happens if it actually works. Israel is betting its future on the sun, specifically on a mega-scale solar installation in the Negev Desert that could fundamentally reshape power dynamics across the Middle East. But behind the ambitious headlines lies a web of engineering nightmares, diplomatic landmines, and financial risks that could turn this project into either the greatest energy achievement of the century or one of the most expensive failures in modern history. The technology exists, the money is there, but building something this large in a place this complicated comes with problems that no amount of solar panels can solve. If you're fascinated by massive engineering projects and the future of global energy, subscribe to Next Blueprint, hit the like button, and drop a comment telling me whether you think this project will unite the region or tear it apart. The Negev Desert covers more than half of Israel's total land area. It is one of the most inhospitable places in the country. Temperatures spike beyond what most humans can tolerate. Rainfall is almost non-existent, and for decades, it was considered essentially worthless for development. But that emptiness is now Israel's greatest asset. Solar farms require three things above all else: sunlight, space, and minimal cloud cover. The Negev delivers all three in abundance. Engineers estimate the region receives over 300 days of direct sunlight per year. The land is flat, government-owned, and far from major population centers, which eliminates most of the zoning and land acquisition battles that slow down renewable projects elsewhere. The vision is staggering in scope. We are talking about thousands of square kilometers covered in photovoltaic panels and concentrated solar power systems. The infrastructure would include massive battery storage facilities capable of holding energy for days, not hours. Transmission lines would stretch across borders into Jordan, Egypt, and potentially further into the Gulf. Initial projections suggest the completed system could generate upwards of 100 gigawatts at peak capacity. For context, the entire United Kingdom runs on roughly 75 gigawatts during high demand. Israel wants to build something bigger, in a desert, surrounded by nations with whom it has a complicated history, to put it lightly. But here is where the first cracks appear. Deserts are brutal on solar technology. Sand particles erode panel surfaces. Extreme heat actually reduces the efficiency of photovoltaic cells, and the infrastructure required to cool concentrated solar systems demands water, a resource the Negev does not have in abundance. Engineers are already debating whether the project's long-term maintenance costs could spiral out of control. $50 billion is not a guess. It is a conservative floor estimate for what this project would require over the next 2 decades. That figure includes panel manufacturing, battery storage, transmission infrastructure, labor, land preparation, and the diplomatic costs of negotiating cross-border energy agreements. But some analysts believe the real number could climb much higher, especially when factoring in inevitable delays, political disruptions, and the challenge of building in a region where construction projects routinely face security concerns. Israel's government has signaled its willingness to fund a substantial portion through sovereign investment, but the scale demands international capital. That means courting foreign investors, some of whom may be uneasy about pouring money into a project that depends on stable relationships between Israel and its neighbors. Private equity firms have reportedly shown interest, but only with significant guarantees against political risk. Insurance costs alone for a project this large in this location could run into the billions. Critics point to another problem. Return on investment is uncertain. Solar energy prices have plummeted globally, which is good for consumers but troubling for investors expecting premium returns. If neighboring countries can build their own solar capacity for less, why would they buy electricity from Israel? The economic model assumes demand will outpace regional supply for decades. But Saudi Arabia, the UAE, and Egypt are all pursuing their own renewable mega projects. Israel may be building a product that its intended customers no longer need by the time it is finished. If that surprises you, hit like because the financial risks are just the beginning. Building a solar farm is straightforward. Building the largest solar farm in human history in an active geopolitical flashpoint under extreme environmental conditions is something else else entirely. The engineering challenges begin with the basics and escalate from there. First, the panels themselves. Standard photovoltaic cells lose efficiency as temperatures rise. The Negev regularly hits temperatures where performance degrades by 15 to 25%. Engineers are exploring advanced cooling systems, but each solution adds cost and complexity. Some designs call for elevated panel arrays that allow airflow underneath. Others propose hybrid systems that capture waste heat for secondary power generation. None of these have been tested at the scale Israel is proposing. Second, the storage problem. Solar power is only useful when the sun is shining. To supply energy around the clock, Israel needs battery capacity that dwarfs anything currently in operation. Lithium-ion remains the dominant technology, but sourcing enough lithium for a project this size would strain global supply chains. Alternatives like solid-state batteries and flow batteries are promising but unproven at scale. Some engineers suggest the project should incorporate pumped hydro storage, but that requires water and elevation changes the Negev does not naturally provide. Third, transmission. Getting power from the Negev to population centers in Israel is manageable. Getting it across international borders is a different challenge. High-voltage direct current lines would need to cross territories with unstable governments, contested borders, and active conflict zones. A single attack on a transmission tower could black out entire grids. The security infrastructure required to protect these lines would be enormous and ongoing. There is also the question of dust. The Negev experiences frequent sandstorms that coat panels in fine particles, reducing output by up to 30% until they are cleaned. At this scale, cleaning would require automated robotic systems or water-intensive washing, both of which add operational costs that compound over time. Energy projects of this magnitude are never just about energy. They are about power in every sense of the word. Israel exporting electricity to Jordan, Egypt, Saudi Arabia, or the Gulf states would represent a fundamental shift in regional relationships. Some see this as a path to peace. Shared infrastructure creates mutual dependence, and mutual dependence discourages conflict. The logic echoes post-war Europe, where coal and steel agreements laid the foundation for decades of stability. But the Middle East is not Europe. Historical grievances run deep. Normalization agreements like the Abraham Accords have opened doors, but public opinion in many Arab nations remains skeptical of ties with Israel. A power grid that makes Cairo or Amman dependent on Israeli electricity could become a political liability for local governments, especially if prices rise or supply falters. There is also the Iran factor. Tehran views Israeli influence in the region as an existential threat. A project that positions Israel as the energy backbone of the Middle East would almost certainly provoke a response. Cyber attacks on grid infrastructure are already common globally. A target this valuable, this symbolic, would attract state-level threats that go far beyond conventional sabotage. Even Israel's allies have raised concerns. Some experts argue that concentrating so much critical infrastructure in one location creates a single point of failure. A coordinated strike, a catastrophic equipment failure, or even a severe sandstorm lasting weeks could destabilize power across multiple countries simultaneously. Comment below if you think energy cooperation can survive politics in this part of the world. Israel is not the only country chasing solar supremacy in the region. Saudi Arabia's NEOM project includes a solar component that rivals anything Israel has proposed. The UAE has already completed some of the world's largest solar installations. Egypt is expanding its Benban solar park. Morocco's Noor Ouarzazate complex is a proven success story. The Middle East is in the midst of a renewable energy arms race, and Israel is not necessarily winning. The competitive pressure creates a dangerous incentive to move fast. Rushing a project of this scale increases the likelihood of cost overruns, engineering mistakes, and safety failures. Some industry observers worry that the $50 billion figure assumes best-case timelines that have never been achieved in the solar industry at this level. There is also the question of technological obsolescence. Solar technology is advancing rapidly. Panels installed today will be significantly less efficient than panels available in 10 years. If the project takes 2 decades to complete, early installations may need replacement before the system is even fully operational. Building for the future means building with technology that does not yet exist, which adds uncertainty to every cost estimate and performance projection. Some experts believe Israel's real advantage is not size, but integration. A smaller, more advanced system with cutting-edge storage and smart grid technology could outperform brute force capacity. But that is not the project being proposed. The current vision prioritizes scale, and scale comes with risks that precision cannot eliminate. Subscribe for more deep dives into the future of energy and technology. Imagine for a moment that the project works. Every panel installed, every battery operational, every transmission line secure. What happens next? Israel would become the energy hub of the Middle East. Countries that currently rely on oil and gas imports would have access to cheap, renewable electricity. Carbon emissions across the region would plummet. Desalination plants powered by solar energy could address chronic water shortages. Air conditioning, which consumes enormous power in Gulf climates, would become more sustainable. The economic ripple effects could be transformative. But success also means dependence. Nations that buy Israeli electricity become vulnerable to supply disruptions, price manipulation, or political leverage. Energy has always been a tool of geopolitics, and there is no reason to believe renewable energy will be different. Some analysts warn that trading oil dependence for solar dependence simply shifts the balance of power without eliminating the underlying tensions. There is also the domestic debate within Israel. Building this project means diverting resources from other priorities. Critics argue the money would be better spent on housing, healthcare, or defense. Supporters counter that energy independence and export revenue will fund those priorities for generations. The political battle over allocation is just beginning. And then there is the environmental irony. Covering thousands of square kilometers of desert with industrial infrastructure is not without ecological cost. The Negev is not lifeless. It supports unique ecosystems, endangered species, and Bedouin communities with historical claims to the land. Balancing renewable energy goals with environmental and social responsibility is a challenge that every megaproject faces, and few resolve cleanly. 20 years from now, the Negev could be the most important piece of land in the Middle East. Not for oil, not for religious significance, but for the energy that powers a region transitioning away from fossil fuels. If this project succeeds, it will redefine what is possible in renewable energy. It will prove that even the most hostile environments, the most fractured political landscapes, can be unified by a shared need for power. But if it fails, the consequences will echo for decades. Billions in lost investment, a setback for solar energy credibility, deepened mistrust between nations that almost found a reason to cooperate. The stakes are not just financial or technical. They are existential for a region that has spent a century fighting over resources. The sun will keep shining over the Negev regardless. The question is whether humanity can build something worthy of that gift, whether engineers, politicians, investors, and ordinary citizens can align around a vision that serves everyone, not just the powerful. Whether the Middle East can write a new story, one measured in gigawatts instead of grievances. The next chapter has not been written yet, but the first lines are being drafted right now in blueprints and boardrooms, in diplomatic cables and desert surveys. If you want more stories about the technology shaping our future, subscribe to Next Blueprint, like the video, and share your thoughts in the comments. I will see you in the next one.